Uh, Hello everyone. I would like to show you how to activate the data analysis add-in for Excel first, and then I try to go through some of the problems in your textbook. First, you open Excel as long as you have a Windows-based computer. You open Excel, and then you go to the Office button. Then under the Office button, you see Excel options. Right now, when you go to Excel option, on the left side you see add-ins. You click on that, and it gives you the list of add-in available for Excel 2007. I think many of these add-ins they are very important, but the one that we are going to use today, it's known as Analyst Tool Pack. So we click on that one, and we click on Go here. It gives you a dialog box, and using that dialog box, you would be able to activate the first one, which is Analyst Toolpack. And now, if you look at my screen right now on the uh, right side, there is nothing there. But if I activate the Analyst Toolpack and click on OK, you can see the data analysis toolbars is active now. So right now, if I'm gonna use Excel for my DS class, I think this would be a good idea to go to data analysis here and see what I have underneath that. So when I go over this, they give you the list of the available statistical method, and many of them very useful for DS 2333 as well as for DS 2334. So right now, let me try to solve some of the problem with the help of Excel data analysis add-in. Uh, First problem I am considering is problem 2.85. That one is in your textbook, is on page 71. And basically dealing with the 50 observation. It's in your textbook is known as furniture's file, data file. If you read that problem carefully, you need to construct a frequency distribution and percentage distribution for part A. For part B, you need to construct histogram and percentage polygon. And for part C, you need to construct cumulative percentage distribution and plot them. So basically what I really need to do here, first look at the range of my data. And in order to do that, let me right now copy this data somewhere else. And let me sort it. So right now I'm trying to sort my data. By right-clicking, I get the option to sort it. And now it's from 1 up to the largest one is 165. And so the range of my data is 165, which is basically 164. And let me, based on the range, try to create what in Excel call it bins. And the bins for these data, let me start from 0 and increment it by 25. And go to up to 150. So these are the bins I created. I could type it also. Let me enlarge it so I can see it better. These would be like similar to different classes I could create for my histogram or for frequency distribution. So let me now go to data and go to the data analysis and go to histogram. And the very first thing it's going to ask me is the input range. It's actually, I already stored it here from H1 to H51, and then it's asking me about the lens range. It's gonna be from um, N1 to N8, and if you recall, I put label in the first row, so I have to make sure I click on this one. And lastly, it's asking me for where I want to have the result. Let me put the result close by. Let me put it in Q here. And now I want to have a cumulative percentage. And basically, I can ask for other graph as well. And let's say chart output. So I'm going to click on OK now. It's going to go through and provide me some information which is useful. First of all, let me make it a little larger so I can see it better. Uh, it goes through the frequency and basically come up with the frequency for each bin. And then it comes up with cumulative one, and eventually it plots the histogram for it. So if I'm looking at the histogram, the blue rectangular is my histogram. And eventually, I'm looking at the cumulative one. It's the red one. Red curve is the cumulative one. And so if I have to make a decision about this data, it's the number of the date that until complaint has been made and the complaint has been resolved. You see that most of the complaint have been taking about like a 25 or 50 days. So most of them, they are in this neighborhood. Now, let me enlarge it. So again, it would be useful to look at these further. And if you want to use Excel, I think this is one way to come up with the histogram, come up with the cumulative one, come up with the frequency distribution, and so on. Now, let me move on to another problem, problem 3.13. And that problem, it is again from your textbook. And when I'm reading that problem, it's on page 111. It's dealing with the chocolate chips cookies and basically the cost of it in cents for 1 ounce. And here you have to find the mean, median, mode, and find variance, standard deviation, all those statistical measures. So this would be the type that I'm going to again go to the data tab and I go to the data analysis. What I'm really interested in is descriptive statistic. And since I already have the data, I'll go and select it. It's going to be from A1 to A14. Again, label is in the first row and the data is given in a column. And now I want to put the information at front of me. So let me put it in, let's say, F1 column, F column, row 1. And then I need a summary statistic. And that's all I need to have. So by clicking on this, Excel is going to go through the data and come up with different descriptive statistics. And now if you look, the output is already here. And let me enlarge it a little bit so I can see it better. So now looking at the average or mean is 33.69. Now, I don't like that color. Let me change it back. Let me put a color this way. Now, if you look at the median is 36. Look at the mode is 25. And look at the standard deviation. It is 13.57. And sample variance is 184.23. So all these information are very, very useful and we can use them. So if you use this information, you can answer definitely part A of your problem on page 111, uh, problem number 3.13. You can easily answer part B. Only part that they ask you is find out the z-score, which I think you need a little more. What you need to do here, let's create a column right adjacent to your data. And again, let's enlarge it. So whatever we get, we would be able to see. What you need to do is your data, in this case, store it in a column, row 2, minus what's the mean? The mean here is 33.69. I could use number or could use address. Let me use the absolute address. It is G3, and I divide that by standard deviation, which is stored in G7. Again, I'm using absolute address. Uh, so when I do this, the first z-score is 1.49. And since I used absolute address, I could go and do it for the rest by using the fill handle. And I have the z-score for all of them. Relatively easy, I could get them. Remember, I used the absolute address. That's why when I use the fill handle, the address didn't change. It stay as G3 for mean and G7 for standard deviation. Uh, one more thing to note here is the z-score is your data minus its mean. In this case, it is stored in G3 divided by its standard deviation, which in this case, it's stored in G7. So right now, I think I have no difficulty answering part B. And is there any outliers? Usually, you have to look at the z-score and see if any of them are outside minus and plus 3. In this case, when I'm looking at the observation I have for z-score, and none of them would be outside minus 3 and plus 3. In some books, they may use minus 2 and plus 2, but still for this data set, all of the observation are between minus 2 and plus 2. So there is no outlier. There is no extreme value. And then they're asking about the data, the shape of the data. Usually you can try to answer this by looking at the mean and median, and based on comparing these two with also mode, you would be able to answer these questions. So right now, by just comparing mean and median is obviously more than mean. So if mean is somewhere like a 33.69, median is uh, more than that. So if I have to make a decision here, I think it is skewed to the left. Uh, it's negative skewed because median is bigger based on that. But obviously here I didn't consider the mode. That's another measure I could use. So I guess another way to do this to get the histogram of the data, but the data is not that many observations, so it's not going to give you definite answer. So now let me move on to problem. The next problem, 3.13, is completed. Now let me go to 3.46. 3.46, it's given on page 130. And in this problem, you are interested in finding what is known as a correlation coefficient. If you try to do this manually, it's going to be time consuming. But if you use Excel, especially if you use the data analysis tool of Excel, it's very fast. So here, let's say this is like my X, and this would be my Y. The second, it is my X, and this would be my Y. So let me just right away go to the data analysis. And going to the data analysis, I could get the covariance, but I really didn't cover that in a class. I just covered what is known as a correlation coefficient, which is giving you better information than covariance. So if I ask for that one, it's going to come up and say, where is your data? Obviously, the data is here. I want to find out if there is a relationship between the calories, amount of calories and the sugars in different cereals. So I put the information in B1 through B8, and I ask Excel to go there. Obviously, again, the label is in the first row because I have a calories and sugar there. And lastly, I want to ask the information to be at front, to be given on the same screen. So let me just put it in F1, column F, row 1. So right now, if I say OK, it's going to go through and it's going to tell me basically what's the correlation between calories and sugars. It's right here. Let me again enlarge it so I can see it better. The correlation between calories and sugars, amount of sugars, it's 0.839, 0.84 roughly. And that's relatively high. And I can see the same information if I would have plot this. Basically, if I plot these two, let me just go use a regular Excel to plot this. Let me use a scatter diagram. Uh, if you look at this, it scatter diagram, it gives you the plot of your data. And right now, when I'm looking at this, there seems to be a correlation when the, let's say, looking at the calories and sugar amount of sugars, you see when I increase sugars or when I increase the one variable, the other one increase as well. So it's like a positive relationship. Last thing to note is that correlation coefficient is between -1 and +1. Definitely this is a positive one and it's very close to 1, it's 0.84. So we can say there is a positive correlation between the two. Thanks a lot. If you have any issue, please let me know and take care.